And today I'll be taking you guys controlling the flow of execution and loops. By controlling the flow of execution, we simply mean how do we want our program to execute? Do we want it to say yes when somebody inputs, do I have money? Or do you want it to say no? Giving a real life example will be our tap, the tap in our household literally controls the flow of the water, in the sense that if we turn it on, water flows. If you turn it off, water stops flowing. Now, if going down to controlling the flows of the execution, in Python it simply means conditions. Whenever you just hear controlling execution flow, it simply means conditions. And by conditions, we have the if condition, we have the if else, we have the if else condition. The first form is the if condition. The if condition is the simplest form, is the basic form of the condition. It compares between two values. All of them is the same thing, but all of them compares between values, except the else. But the if compares between two values, as you can see here, if user data equals to yes. I will show you what I mean, because I'll go to my editor now. Now, starting with an if, let's get user input. Now, with an if statement, ask if it's yes, if user data equals to yes, we print can you give now if we run this, it will just ask us one question: do you have money? If you put yes, it will print can you give me some. If you put no, nothing happens. Let me run it to show you that. As you can see, can you give me some? Because I said yes. Try it again. If I put no, nothing happens. Let me try it again. If I put no, as you can see, nothing happens. So I believe that should explain how the if statement works. Now, if we go back to the if else, we can see that it's basically the same thing with this. The only difference is now, as we imputed no in this particular one, no here, it doesn't tell us anything. It just exits nothing without giving us any information or whatever. And else block will give us something, as long as the answer is not yes. As long as whatever we put as an answer is not yes, it will tell us something. And I'll do that now. Meantime, let's see. Okay, if I run this and I start with yes, can you give me some, as expected. If I run this again and I start and I put no, do you ever agree? And if I now put something else to something like it teaches us, do you ever agree? Because the answer is not yes. As once the answer is not yes, it will keep on printing these statements no matter what we put. Even if we put SA, like by SA I just mean just type one letter A. You can see the letter A here. I'll zoom in more. You can see the letter A there. Now going to the if else block, I will be providing the document, so in case you want to read it through. The if else. Now what this if simply means is else if. That is what it means, else if. Explaining this now means, as we can see here, the user, it only checks if it is yes. It doesn't check if it's no. Only yes. It's only what we are concerned about. Now, and a user cannot always have money. Even if you did, most will not agree. So we now start with an else. You can see it's already there. An else if user equals to no print okay, I'll just leave that okay. If I run this now, I'll put something like if I put no, as you can see, I did put no, but it's both capital letter. I will explain that soon, why it did not work. So as expected, it gave us okay. Now this is just a basic example of it. As you can see, it compares my input with what is already here. If it's yes, it will print can you give me some money. If it's no, it will print okay. If it's none of them, if it's not yes, if it's not no, it will print do you ever agree. Now there are some common operators that we could use, like we could chain commands. By chain commands I mean, you can see this only checks for yes, and if you remember in my previous example before this one here, when I ran it, I used all caps, that is N in caps and O in all caps, and it gave me an error. I'll do that again so you would see what you remember. If I use no, the same thing goes for if I was to use yes too, or if I don't even need to do that, I just need to, if I use just NO2, as much as they both mean the same thing, but in my code I only specified something to happen if it's just NO. Another thing, what I mean is, okay, and sorry about this. If I print this, I'll just answer a question. As you can see, this space gives us this. You can see they are not the same thing. That's what I'm trying to say here. Now, for us to be able to accommodate or to also be able to capture when the user says if the Y starts with a small letter or the N starts with a small letter, we could use something like, we could use one, either this or this, but I'm going to use this because the OR operator checks if one side, if this side, okay, let me just write it. Once I finish writing it, I'll explain that. Or user data was to yes. And what I mean here is this OR operator checks if here gives us yes or here gives us yes, these small letters, it will always be true. If we are to use this AND here, and by true it means we just need one of these statements to be correct, just one to be correct, and it will print this. To print this. But AND, if you are to put AND, it needs both statements to be correct. It means it needs this and this to be correct. If not, it will not print. It will print. Do you ever agree? I'll show you what I mean. If I run that now, no. Okay, that's a mistake. If I put yes now, you can see it no longer gives or tells us do you ever agree. If I put a capital 2, okay, the same thing. If I were to change this all to and, do you see what I mean? It just went straight to do you ever agree. Why did it go straight to do you ever agree? Because this was only provided. It's only one side will be provided. This is not provided. If I change it back to or, it's the same thing with when you're saying something. It's like you're chaining the two of them together. If you say I need bread and coffee, you say you need the two of them. The two of them has to be there. If you said I need bread or coffee, it means you're specifying, okay, if you don't find bread, you can bring coffee or just bring anyone. The same concept applies here. This one, the two of them, this one and this one has to be true for and to give us to print this block for us. And I've explained and or, not. Okay, I'll first explain the in before I explain the not. Now, in checks if it checks if something, like if let me say an object exists in a list, a dictionary, a string, a set, or any other one. Let me give you an example. Let's say names equals to Frank, Mary, and let's see. Now, if I'm checking, I'll change this to now go back here. If user data in name print that's a mistake. Okay. And an else block. Now running this, it asks me for my name. If I put any of the name here, it will give me name already exists. Let me show you what I mean. Mary name already exists and just exited. If I do okay, let me look for something like do. As you can see, welcome do. So you already have an idea of what in means. What it means by in, it checks if this it's here. Not a mistake. If you check this is in this list, as you can see, this is a list. It checks if this user is here. And we tried with Mary, I think, it said yes, it was here, name already exists. Now if I check for, if I was to use this not here with this, if user data, if I put not, even if a user data, okay, even if a user's name, the name that is imputed, actually exists in this list, it will still print welcome this, because this not inverts it. It inverts the value of this in, or should I just say, if it was, if the statement was true before and you add not to it, you add not in front of it, it will invert it to false. That's what I mean. So I'll run this and provide a name that we all know that is there. Now let's just say okay, welcome Folake was printed, even if it was actually here. So that's it for this in. And for the is the best way. The is actually compares between the two. Like is similar to something like username equals to let me just say Frank. Is similar to this. I'll show you what I mean. It compares the two of them, but the difference is this one compares the value. Is compares the object itself, like the strings or so. I'll show you what I mean. I put Frank. If I change this to is, you can even see it's giving me an error. It's okay. It's one way people actually do things, so it's not a recommended way. See, did you mean? But if I give it the same Frank, and do you know why I got this welcome Frank? Because this, whatever I'm getting, might be the same with this actually, but they are not the same object. They are not the same object number at all. Let's see. I want to see. Okay. Let me try something. See if print no is no. Let's see. As you can see, it gave us true. If I want to remove this error, let me try something else too. As you can see, we didn't get that error message again. Like I told you, it compares the object itself. It compares the objects. If I was to use as these are the objects themselves. Anyway, so that's actually it for this, for if. Now we move to the loops. I'll leave that user data there. Now loops just simply means repetition of a task. So in Python we have two loops. We have the for loop and the while loop. The for loop is the most common one. Not all of them, like I said here, do the same thing but different ways, in different ways. Now I will be starting with the for loop. For for loop, I'll just write a simple for loop that prints welcome to each of these users here. For I in names, what it does is it takes each user in this list. That is what this means. You see what I mean? Run it. That okay, I didn't need this up again, but well, you can see it. Welcome Frank, welcome Mary, welcome Timmy. That's what this does. It takes each object or character or string here. It doesn't just work for name, it also works for dictionaries, like dictionaries that let me see, something like now you can see welcome age. Okay, I didn't really change this welcome here, but you get the point. Like it also works with a map with this. I think some methods for maps, right? Yes, you can see that in maps, like the previous video of my colleague Toby Mildness explained about dictionaries. Then this is a key, this is a value, a key, a value. You can go through the you can look through the keys or the values or even both of them. Like now, by default, we can only, it was looking through the values. If I look through the oh, I didn't remove that, to the values, you see it changed against the other ones. So to make it more usable, seeable. Okay, as you can see there. So I just wanted to show you for loops with dictionaries. Now, as you can see, there is a common function that is used in for loops. It's called range. By range, it means like it gives a specified amount of, what I said, numbers within within a range or sequence. Like if we want to get the numbers between 1 and 10, we could use a range. An example of what I mean is for I in range 0, 10, print I. If we run this, as you can see, it started from 0 and it stopped at 9. You might be wondering, why did it stop at 9? Why did it stop at, instead, why didn't it stop at 10? It actually stops at this thing. It actually stops at 10, but not in the sense you're thinking of. If you count it, it's going to be 10. It's going to be 10. So usually the stop, like I explained here, this one, we have a stop -1. That's why it's like this. they have a lot of common use for range. You can even use it to loop through this like this. Okay, one example now will be, let me use printing, use the index to get them. You can see Frank, Mary, Falker. Look at what I did here. I got the length of the list and use this, their index, to get them. That's basically it for range. The document contains other values, and I've already explained for loops. Okay, for loops with break and continue. By for loops with break and continue, we mean a for loops that can stop at a certain point and a for loop that can skip. By break, it means if we have something like, okay, I'll use this for example. Here we have something, if I equals to 2, it should continue. By continue, it means it's basically skipping this number 2. These other parts will not get executed. It will just loop over it and move to 3. This one means if I is greater than 15, this break means the loop will just stop. Originally this loop is supposed to continue up to 20, but at 15, once I is greater than 15, it stops, it exits. For this one, okay, it's not used here. This is just to get the even number. I'll copy this and run it so you see what I mean. Don't know if I want. Okay, just remove that. It will be fortunately not formatted well. Okay, if I run this like I've explained, you can see skipping 2. You can see there's no 2 here. Even if 2 is an even number, there's no 2 here. It starts from 4, 6, 8, 10, and like I said, it's supposed to stop at 20. We know that even 16 is an even number, 18 is an even number, 27 is an even number, but where are they? It's not here because of this statement. If I was to remove this, okay, if I remove everything here, cut them out, and rerun it, you can see it went all the way to 18, 16, and so it didn't stop at 15 like it did before. And this one, if I remove this one, you will notice that 2 will be printed here, and this will not print because, well, see what I mean? 2, 4, 6, 2 is here now. So I think that is just basically the concept. The concept of this is it skips. Okay, so forgive me for that. Skips, and this one stops. That's basically what they do in simple terms. Now we'll be moving to the while loop. A while loop is not a for loop, but the difference, well, there's quite some difference. First of all, you don't need this for it to run. A while loop basically operates on a condition. It's similar to the if else, but let's say if else in a loop. It operates on one condition and one condition alone. So if we are writing something like, okay, I'll use the example here. I don't want to, I already have the example here. Oh, sorry, I'll have to, unfortunately. Yes, it's actually an easier way of doing all these ones. Okay. Okay. New user is not defined. Okay. Now, if we run this name, okay, if we run this, let me move this closer. If we run this now, any name we input, as long as it's not here, we'll get this welcome the name to Zurich. But if you input a name that is here, unlike our previous example, that once you input a name that is here, to just exit, I'll have to rerun the program for it to work. Unlike our previous example, this one will not exit. It will keep on asking me to put in another name that is not here. It will only exit if I type in exit or this. Now let me run that to show you. Let's put something like Timmy. As you can see, I should both pick another name. Timmy already exists. Okay, I'll choose another name that I know that exists. It already exists. Now I choose one that I know it doesn't exist. See, it only ended when a name, Eddie, as you can see, there's no Eddie here. It only ended when Eddie was imputed, and the only reason it actually ended was because of this break. If that break wasn't there, it will not work, it will not end. If I was to comment this out, I will comment that out, so you see what I mean. I might put Eddie, so I'll put Eddie again. You see, it keeps on printing, it keeps on printing, it keeps on printing. It keeps on printing Eddie because there was no break this time. And now, if I said after the first time it asked me for a name, let's say I put for Lake, I put this name, and I just got tired. I don't want to sign up again. I don't just want to use the service again, and I put something like exit. It just quits. And this is what I mean by the condition here. The condition, as you can see, is if this new user is that input, not in exit or exit. This simply means is if whatever you're inputting here is not here, is not in this tuple, is not here or here, this whole body should run. But as we imputed exit, you can see that once you just input exit, this whole body doesn't run. It just program finish. It just ends. And I think that will be it for. That's actually it for all this. Then if I was to some things I did not really mention, in this whole loops, function blocks and the rest, we can actually put something like, let's say I don't want to write anything. Okay, in this if block here, I don't want to write anything. I can just put, if I leave it empty, you can already even see there's a red line under this, and you can, if I check my problems, you can see index expected. If I were to put something pass here, like indicated here, you see there's no problem, no red issue here, there's no red this and there. If I run it, it will actually run. It will give me an error. It will give me an error. And I think that's just it for pass. While for this match case is actually similar. It's another, well, I'll say another control flow statement also, because it decide is similar to to if and else conditions. Is that the difference is it doesn't use the if else syntax. It's more like match. You can actually see it's actually here, but I'm not going to talk about it here since it's just introduced in Python 3.10. So if you don't even have 3.10, it won't work for you. And yes, one more thing is in the loops, all of this while loop now, it actually has an else block. Yes, it has an else block. In the else block, it means if, let's say, this is false, if whatever is here is false, it should execute that else block. The same actually goes for loops. There's actually an else block in it. I think I'll just show a simple example. Okay, x equals to y x. I don't need to put an equals to sign or whatever, because what it actually is checking is if something is true, something is false. We could say print x is for x, and I'll break that as the first launch. Then I put an else block here. I'll now okay, instead of breaking it, I'll change the value x equals to false. I'll now print x is x. Now let's run this. I forgot to remove that, but I'll just press anything. Now you can see. Okay, let me to give you more details to that. You can see it from the while loop when x was still true. Once x becomes false, this other part will execute. So that's basically it for all this. And one example I was writing up was to print the Zuri, just Zuri in using asterisks. But the thing was, it's quite a little bit young, so I just wrote it down somewhere else. I'll just show you what it was. Okay, that didn't work. Wrote it down. Now explain it a bit. As you can see, there are loops here. You can see I made use of loops, condition, okay, that's it, and also functions. I only use functions to organize the code well, and if you can see, the functions are ZU. It's actually for Zuri, and here I use double I because the I was somehow interfering with these ones. As you can see, it won't cause a problem actually. You see, if you look there, there's no red distance there. Like, let me write something. Okay, no, won't work. Yes, I forgot to mention this for I can be anything. It mustn't be I. It can be me, whatever you actually want. I put something like you here. So and that's it. And one thing is, I don't know if you noticed, but you can actually multiply strings in Python. By string, is if you still look at this, you can't see anywhere there is Z, U, whatever. So I'll show you what I mean. As you can see now, you can see a Z, you can see a U, you can see an R and I. And if you look at the code, you will not see anywhere that is actually printing like just this whole thing. So as you see, it's using loops and condition. And if you see what I meant by you can multiply, this multiply here is multiplying the space by whatever value this is. So I minus 1, the same thing goes on here, it's multiplying the space by n. And one thing I also did not really mention, but when you're using range can also go, it can count from up and it can count up, it can count down. You know something? What I mean is it can do okay, let me just for x, I think it was x not used. Okay, for x in range, let's start at 10, 0, minus 1. This is a countdown. If we print it, also x, and if you run this, you can see it's down here: 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You can see it. If you wanted it to count up, I'll just need to remove this, change this to 10, change this to 1. See it 1, 2, 3, 4, 5. You might ask me, why did I remove the third term? That one simply states on how the number should be incremented, how it should be changed. If you notice, it was minus 1. It was actually that was doing the whole thing. If I wanted this thing to be going up by 2, I'll just specify 2. Please look at the difference when I run it now. As you can see, 2 plus 1 will give me 3. 3 plus 2 will give me 5. Like that. If I change this to 2, I should get only even numbers. Now see what I mean? Oh, sorry. I'm zooming it in. 2, 4, 6, 8. Like that. And that's basically it. Thank you guys, I'm done. So I will be providing this document like I said, in case you want that. So thank you, and that's all from me, and goodbye.